Could there be a previously unknown planet lurking in the farthest reaches of the solar system? More and more astronomers believe that the elusive Planet 9 might be real, not as a vague conjecture but as a well-supported hypothesis. The unusual anomalies in the Kuiper Belt strongly suggest that a massive celestial body may be hiding there. Even more intriguing, recent research proposes that an undiscovered planet might exist at the very edge of our solar system. But what evidence supports this claim? Why has Planet 9 not been officially confirmed, and why is finding it so challenging? The story of distant celestial bodies began with a question: where do comets originate? This question captivated the Dutch astronomer Jan Hendrik Oort, who proposed in 1950 that a spherical zone of icy bodies at the edge of the solar system, now known as the Oort cloud, serves as a reservoir for comets. While this explained the paths of long-period comets, it could not account for the trajectories of short-period comets. To address this, Gerard Kuiper postulated the existence of a belt-like structure beyond Neptune. Today, the Kuiper Belt is an established feature of astronomy, known to host a variety of icy debris, comets, and dwarf planets. However, there is growing speculation that this belt may conceal something much larger, a giant planet that has evaded detection for centuries. The idea of a hidden planet in the Kuiper Belt is based on compelling evidence. Astronomers have noticed unusual patterns in the orbits of certain Kuiper Belt objects, KBOs, suggesting the gravitational influence of a massive unseen object. One of the leading figures in this investigation is American astronomer Michael Brown, known for discovering Eris, the dwarf planet whose identification played a significant role in Pluto's demotion to a dwarf planet in 2006. Along with his colleague Konstantin Batygin, Brown analyzed the orbits of several distant detached objects and discovered peculiarities that pointed to the presence of Planet 9. 6 of these objects follow elliptical orbits that align in the same direction, a phenomenon that seems improbable by chance. Furthermore, their orbits are tilted at approximately 30 degrees relative to the solar system's primary orbital plane. Brown and Batygin concluded that the probability of these alignments occurring by coincidence is less than 0.7%, making a strong case for the gravitational pull of an undiscovered planet. Initially, some astronomers speculated that the gravitational effects of multiple smaller objects, such as a cluster of dwarf planets, might explain these anomalies. However, further studies showed that the Kuiper Belt would need to be at least 100 times more massive than it is to produce such effects. The simplest and most plausible explanation became the existence of a planet about the size of Neptune. If Planet 9 exists, it is estimated to be 9 to 10 times the mass of Earth and to orbit the Sun at a distance of 400 to 1,500 astronomical units, AU. For perspective, 1 AU is the average distance between Earth and the Sun, roughly 150 million kilometers. This vast distance means that Planet 9 would take approximately 20,000 years to complete a single orbit around the Sun. Its extreme remoteness and faint luminosity make it nearly impossible to detect with conventional telescopes. The planet is believed to emit primarily in the infrared spectrum, with a temperature around 47 Kelvin, -226 degrees Celsius, only slightly warmer than the surrounding space. These factors combine to make Planet 9 an exceptionally dim target for observation. Even so, it may have already appeared in existing sky survey images, hidden in plain sight. The upcoming Vera C. Rubin Observatory, set to begin operations in 2025, could be instrumental in finally detecting this elusive world. Why has Planet 9 remained undiscovered for so long? Its immense distance from the Sun places it far beyond the reach of most telescopes, and its faintness makes direct detection extraordinarily difficult. Even if the planet were at its closest point to the Sun, its intrinsic brightness would be so low that it might easily go unnoticed. Additionally, its long orbital period means it spends most of its time in the darkest, most distant regions of the solar system. Despite these challenges, hope remains. If Planet 9 is currently near its perihelion, closest approach to the Sun, it might appear in older astronomical data. If it is farther out, advanced telescopes like the Vera Rubin Observatory or even the James Webb Space Telescope could eventually confirm its existence. The confirmation of Planet 9 would be a monumental discovery, but it would also raise new questions. According to standard planetary formation theories, large planets form in regions of the solar system where the primordial gas and dust cloud is sufficiently dense to provide the necessary building materials. However, Planet 9's estimated location, averaging $700 from the Sun, lies far beyond this zone. How could a planet of such size and composition form in such a sparse environment? Astronomers have proposed several theories to explain this conundrum. One possibility is that Planet 9 formed closer to the Sun and was later ejected to its current orbit due to gravitational interactions with other giant planets. Alternatively, it may have been captured from another star system during the Sun's early life in a stellar cluster. A third hypothesis suggests that Planet 9 originated in the inner regions of the solar system and was pushed outward through gravitational turbulence during the solar system's formative years. Despite the lack of direct evidence, the search for Planet 9 continues to gain momentum. Upcoming advancements in telescope technology, combined with meticulous analysis of existing astronomical data, could finally unveil this hidden world. The Vera Rubin Observatory, with its state-of-the-art reflecting telescope, is expected to significantly enhance our ability to detect faint, distant objects in the Kuiper Belt and beyond. The discovery of Planet 9 would not only expand our understanding of the solar system but also challenge existing models of planetary formation. It could provide valuable insights into the dynamics of planetary migration and the interactions between celestial bodies during the early stages of the solar system's evolution. To fully appreciate the significance of Planet 9's potential existence, one must understand the peculiar dynamics of the Kuiper Belt, a region rich in icy debris and remnants of the solar system's formation. Extending just beyond Neptune's orbit to about $50, the Kuiper Belt has revealed a wealth of information about the solar system's early days. Dwarf planets like Pluto, Haumea, and Makemake, along with numerous smaller objects, inhabit this region. However, what makes the Kuiper Belt particularly intriguing is its anomalies. The peculiar clustering of certain objects' orbits strongly suggests the influence of an unseen gravitational force. These objects, known as Extreme Trans-Neptunian Objects, ETNOs, appear to be shepherded into their unusual paths by a massive, distant body, hypothetically, Planet 9. The predicted orbit of Planet 9 is one of the most extreme in the solar system. Its average distance of 400 to 1,500 AU places it well into the outermost reaches of the solar system, far beyond the influence of the inner planets. Unlike the nearly circular orbits of the 8 known planets, Planet 9's orbit is expected to be highly elliptical, with an inclination tilted relative to the solar system's plane. This unusual orbit plays a key role in explaining the observed behavior of KBOs and ETNOs. It is thought to create a gravitational, shepherding effect, aligning the orbits of smaller bodies in ways that defy conventional expectations. These findings not only strengthen the case for Planet 9 but also suggest that its discovery could revolutionize our understanding of planetary dynamics. Detecting celestial bodies at such great distances is an enormous challenge. Even Neptune, a massive planet located just $30 from the Sun, appears as a tiny, faint dot to ground-based telescopes. Planet 9, at its predicted distance, would be even dimmer, so faint that its intrinsic brightness might escape detection in visible light altogether. Instead, astronomers are turning to infrared observations. Bodies at such distances are incredibly cold, emitting most of their energy in the infrared spectrum. Advanced instruments, like those on the James Webb Space Telescope, are capable of detecting these faint heat signatures, offering hope for identifying Planet 9 indirectly. Additionally, astronomers are scouring archival sky survey data for signs of Planet 9. Large-scale surveys like those conducted by the Pan-STARRS Observatory or the Wide Field Infrared Survey Explorer, WISE, may have already captured its faint signal without realizing it. The meticulous reanalysis of this data could prove instrumental in solving the mystery. Thank you for exploring the mysteries of the cosmos with Space Lab. Don't forget to like, subscribe, and join us on this journey to uncover the secrets of the universe. Keep looking up.